Hello everybody. Today we're going to finish off 4 decimal 2 part 2. We finished off at example C last day, so we're going to do D through I. These are just some different types of factoring again, and then we're actually solving for x because they're equal to 0. They're equations. So you set your factors equal to 0 and solve for x. All right, so the next one here, we'll notice we have 2x squared minus 24x plus 54. You'll notice that there's a coefficient of 2 up front, so hopefully we can factor the 2 out. And you'll notice that we can do that due to the fact that every number is even, right? So I'm going to pull the 2 out at the beginning here. That's my first step. All right, bracket, and then it'll be x squared minus 12x plus 27. There's the first step. And of course that's equal to 0. And then we will factor the trinomial, right? So we copy this, or no, let's put the 2. So it'll be 2 bracket, 2 bracket, and then we have x minus 3 and x minus 9. Two numbers multiplied together to give me positive 27, added together to give me negative 12 are negative 3 and negative 9. Now we set them equal to 0. So the 2 we don't need for now. I wouldn't divide that out because it's still part of the equation. I mean, you could, but now is when we set our 2 factors equal to 0. Obviously the factors that have x on them, right? We can drop the brackets at this step. All right. Right, so we have 2, we separate them, set them equal to 0. So this will tell us that we have x equal, we have x equal to 3 and x equal to 9. And there we are. Then you could verify that back in, plugging them in. I'll do it quickly with you. 3 squared is 9, 9 times 2 is 18. 3 multiplied by negative 24 is negative 72, right? Negative 72 plus 54 is 18, and 18, subtract 18. There you go. So there's just one quick verification. Let's look at the next one. We can look at example E. So in example E here, we have, you can tell it's a difference of squares. X squared is a perfect square, 64 is a perfect square, and you're taking the difference of them. So we just take the square root of x, we get, or x squared, we get x. We take the square root of 64, we get 8. So it's going to be x minus 8 and x plus 8. And of course it's equal to 0. So you can set the both factors equal to 0 at this point in time if you wish, or you can just say that x is equal to plus or minus 8, as you're obviously aware. It's up to you. I'm just showing each step. Like I said, some people could skip this last step. And then I would say that x is equal to positive 8 right here, and x is equal to negative 8, right? There. And example F, set this equal to 0. So you'll notice the when you're solving these by factoring, you'll have to set it equal to 0 first. So I will rewrite this. We have x squared. We'll take the 10x over, so it'll be minus 10x, and then the plus. The subtract 16 on the right hand side, we add 16 to the left hand side, and there we go. We bring everything to the right. So for the left hand side, set the right hand side equal to 0. And now we just factor. Two numbers multiplied together to give me 16, added together to give me negative 10 would be 8 and, negative 8 and negative 2. Right? Negative 8, negative 2. That's equal to 0. And then, of course, we set both factors equal to 0. Alright, and you can drop the brackets at this stage of the game. Put it over here until I forgot, not that it makes a difference. Alright, and then we say that x is equal to positive 8 and x is equal to positive 2. And you can just, you don't have to say positive, you can just say 8. It's fine. Alright. Next down here we have an interesting question. This is one I find comes up quite a bit where we have no, well, I shouldn't say we have no y-intercept, but there's no, the y-intercept is 0. I guess it'd be a better way for me to describe this. So what you need to do is, all you do is you factor out a GCF of the first two, which is just x, right? So we have x, so x, and then we have bracket x minus 9 equal to 0. Now we set both factors. Remember, x is a factor 2. I'll put in brackets if you're more comfortable. You don't need to, but you can. So that means that x is equal to 0. And x minus 9 is equal to 0. We can drop our brackets. And then that means that this x is x. Oh, x equals 9. Right? Add the 9 to both sides, we get x equal to 9. Okay? If you look at h is another specialty polynomial. You'll notice that it's a difference of squares again. 25x squared is it's perfect. We can change that into 5x, right? Take the square root of that, and 49 is perfect square. That's 7 squared. So this is the difference of squares. So we write this as 5x, or bracket, sorry, 5x minus 9 and 5x plus 9. That's equal to 0. And you set both factors equal to 0. Set both factors equal to, oh, sorry, that should be 7. Don't mind me. The square root, you guys are looking and saying, what's that? Square root of 49 is 7, not 9. I do apologize. And then we have 5x equal to 7. The 7 over to both sides, and then the opposite side would be obviously 5x equal to negative 7. Right? As you subtract the 7 from both sides. There you are. And then divide both sides by 5, obviously. And we get x equal to 7/5. And this side here would x equal negative 7/5, obviously. And you're done. That's it. The next one's a neat one. People see the a value of 1/3. I get all out of gear. So here's how I approach this question. Again, you may see different approaches or different strategies, but what I do is I do the exact same thing I did in F. First thing is to set it equal to 0. That's the first thing you want to do. All right. So the first thing we're going to do is we're going to set this thing equal to 0. So we got the 1/3 x squared plus 5x, because it's negative on the right hand side, plus 18 equal to 0. That would be your first step here. All right. And if I was looking at this, I'm saying, okay, how do I factor this? Well, an a value of 1/3, what I would like to do is I would like to get rid of the 1/3. So when I say get rid of the 1/3, how will I do that? Basically what I want to do is I want to make the a value 1. So I just multiply that term by 3. And if I multiply that term by 3, that means I have to multiply every term by 3. So I'm going to literally take this and I'm going to put it in brackets. And I'm going to multiply every term in the brackets by 3. And then I'll do the same thing to the Remember, what you do to one side, you do to the other. Three times 0 is not going to change anything, right? And that's the beauty of solving for equations. Unlike a function, you couldn't do that, right? Because then it'd be 3y. But here, it's an equation. It's equal to 0. So we multiply 3 by 0, it just makes it 0, which is nice. So I'm going to clean this up again and grab that for a second. So 1/3 times 3 is 1. That's why we did it. 5 times 1/3 is 15. And 18 times 1/3 is 54. And 3 times 0 is obviously 0. So then we have this beautiful simply factorable trinomial. Two numbers multiplied together give me 54. Added together give me 15, or 5 and, or sorry, 9 and 6. I do apologize. 9 and 6, or 6 and 9. All right, and that's it. So then we just say bracket x x sorry about that, x plus 6, x plus 9 equals 0. And that simply means that x is equal to negative 6, and x is equal to negative 9. Right? That's it. You notice I skipped a step there. You know, as you get the hang of these, you get a little more comfortable with them. That's fine. So there's some more factoring and solving for x. So first we do is we set the sides equal to 0, and then we do some factoring that we learned in Math 10, Math 11, and yesterday in the previous section of 4.1 part, or sorry, 4.1 part 2. So factoring, like I mentioned, is you know, it's a big part of what we do in mathematics, and it's not going to go away, right? So I definitely recommend we you know, we practice our factoring. So that's it for this video. We'll pick it up at 4.3 next time. So hope you're enjoying the videos. I hope they're working for you. If you have any questions, make sure you please ask in class. And thanks again.